Hello, ladies and gentlemen. Today we are going to take a look at some story problems, some applications, as well as discuss what it means to be an inverse. So we need to have our calculators ready and taking down some notes as we work through a few story problems together, and you'll be writing down a few general hints about dealing with the inverse. So remember that uses of trigonometry are widely varied, okay? But most of the time we see them being used to measure distances or lengths of objects that cannot otherwise be measured. So that indirect measurement technique. This is one of those situations. So let's say that we're at a point on the ground 50 feet from the foot of a tree, and the angle of elevation, or the angle looking up to the top of the tree, is 53 degrees. We can find the height of the tree. So let's go ahead and draw a rough sketch of what's happening here. We have a tree. There we go. Nice looking tree. We have the ground. Oh, again, let's make sure the tree comes out of the ground. There we go. And we have a point on the ground that is 50 feet from the foot of the tree. And we can look up from that point at an angle of elevation, that's what that means, looking up, of 53 degrees. And we want to find the height of the tree. So remembering that this would make a right triangle, we can set up one of those trigonometry ratios to help us solve for x. So 53 is the acute angle. We have the opposite side labeled with an x. We have the adjacent side labeled with 50. Opposite and adjacent, we would set up the tangent ratio. So tangent of 53 equals opposite over adjacent. And now we could go to our calculator and type in the tangent of 53 and get that decimal value if we want. Remember to leave 4 decimal places. Or we could just place this over 1 right now. Cross multiply. 1 times x is x. Tangent of 53 times 50. So we would go ahead to our calculator and get the tangent of 53, which is about 1.3270, and then we would multiply that answer times 50. We get 66.4 approximately feet. So the height of the tree is approximately 66.4 feet. All right, let's take a look at another example. This one takes us on a journey to Washington, D.C. So in Washington, D.C., the Washington Monument is 555 feet tall. If the angle of elevation for your line of sight is 75 degrees, how far away are you from the base? So let's draw a rough sketch again. Washington Monument, the ground, and me. It says my eyes are 5 feet from the ground, so I'm just going to keep track of that over here. And the Washington Monument is 555 feet tall. It says I'm looking up at the Washington Monument at an angle of elevation of 75 degrees. Now the problem is 75 has to go in a vertex of a triangle here, and we don't have a triangle. We have this kind of odd-shaped trapezoid here, not a triangle. Remember that normal line of sight, or line of sight, is a straight horizontal line, a vision line, okay? So if you're looking straight ahead, this would be your horizontal normal line of sight. So when you're looking up at 75 degrees, we're saying we're changing our normal line of sight to this 75-degree angle right here. So now we do have a triangle. Here's my triangle, right? The only problem is the vertical line here in my triangle is not 555 feet anymore. Now it's 550 feet because that extra 5 feet, that information about my eyes being 5 feet from the ground, that's where that came in. Now we need to find out how far we are standing away from the base. So I'm going to put an x right here. And now again, we would want to use one of those tangent ratios because I have opposite and adjacent. So I do tangent 75 equals opposite 550 over x. Now once again, we're just going to cross multiply here to solve. 1 times 550 is 550. Tangent of 75 times x would be tangent of 75, that decimal, times x. Now in order to get rid of that, or divide here, we would divide by the tangent of 75 to get the x alone. So I get x equals, now I type in my calculator, 550 divided by the tangent of 75 degrees. And then I end up with a measurement of 147.4. So I'm approximately 147.4 feet from the base of the Washington Monument. All right, let's look at another one. This time we're talking about a lighthouse that sits atop a cliff. It says a 60-foot lighthouse sits atop a cliff at 150 feet. The angle of depression to a boat is 27 degrees. Find the distance from the boat to the base of the cliff. All right, cliff, here we go. There's my cliff and a very rough sketch of a lighthouse. 60 feet and 150 feet for my cliff. And we must have some water down here, perhaps because we have a boat in the water. Doop, doop. Nice little boat. And what we're talking about here when we talk about an angle of depression is an angle that we should make of this triangle here. So basically, yes, we have this looking down situation to the boat. However, where does that angle of depression go? It's not here where you would think. Remember normal line of sight. Normal line of sight is this horizontal line from my lighthouse straight over. This measurement here, the distance that I would turn from my normal line of sight looking down, that is 27 degrees. That is the angle of depression. So that measurement isn't really in my triangle right here. However, I could subtract from 90 degrees to find out how many degrees is actually in my triangle, and that would be 63. You could also label the 27 down here at the boat because that would be correct because the lines would be parallel and you'd have alternate interior angles. But either way, you need to get a measurement that's actually inside of your triangle, and that 27 degrees isn't inside up here, okay? This is that 90-degree measurement. We're finding this distance x down here. Let's keep in mind that this is one big triangle here. And if I am located here at this 63 degrees and my x is opposite and my 150 is adjacent, then I would do another tangent. I'd say tangent of 63 degrees equals opposite over adjacent. Now be careful, adjacent, this whole side is actually 150 plus 60 more. So that's 210. So again, I would place this over 1 and cross multiply. 1 times x is just x. Good deal. X is alone. Tangent of 63 times 210. So I'll type in the tangent of 63 times 210 gives me a value of 412.1 feet. So the boat is approximately 412.1 feet away from the base of the cliff. All right, let's look at another one, another situation. This time we're visiting the Statue of Liberty. So we are standing 100 feet from the Statue of Liberty. So I'm going to go ahead and draw the ground here. Statue of Liberty. Oh boy, this could be interesting. There's a coat sort of thing. Oh boy, this is a very rough sketch of the Statue of Liberty. Yikes, people. I know what you're thinking. Wonderful art skills. There we go, and there she's like holding a book. Oh, looks great, doesn't it? She wasn't really smiling if I remember right. There we go. And now we are standing 100 feet away from this Statue of Liberty. So we will be over here, 100 feet away. Our eyes again are 5 feet from the ground. And the statue is 305 feet tall. What is the angle of elevation from your line of sight to the top of the statue? So this situation is asking us to look up again at the Statue of Liberty. And remember, when we do this, we draw in our normal line of sight. And we can make that right triangle here. Now this vertical line would not be exactly 305 anymore. It would be 300 feet in the triangle because of that extra 5 feet at the base. And now we would say we're trying to find, this would be 100 feet here, this angle. It's asking us what is the angle of elevation for your line of sight to the top of the statue. So you're trying to locate this angle right here. Well, we would set it up the same way. I'm still going to do a tangent here because I actually have opposite and adjacent again. So we would do tangent, but this time I don't have the angle, so I'm just going to leave it as theta equals opposite over adjacent. Now, I'm trying to solve for theta. I'm trying to figure out what that theta is. But in this situation, how would I get theta alone? Can I divide by the word tan to get rid of it? The answer to that is no. When you're trying to solve for an angle, you still set up the tangent or the sine or the cosine, the ratio the same way, but in order to isolate the theta, in order to solve for the angle, if you will, you have to use inverse. So here's the part you need to get in your notes that's brand new to us today. If you're trying to calculate the angle, you will need to use the inverse sine, cosine, or tangent to solve the equation. So symbolically, we're looking for these symbols on our calculator as well. Symbolically, this means the sine inverse. The little negative one, what looks like an exponent here, is really representing inverse. You use that a lot in upper level math classes. Cosine inverse, tangent inverse. So we're going to undo the word tangent. If I go back to our original problem here, we're going to undo the word tangent by writing tangent inverse of both sides. So I'm going to tangent inverse that side, and I'm also going to tangent inverse this side. Well, if I tangent inverse and I have a tangent, that's how I isolate my theta. And now I just need to type in my calculator tangent inverse of 300 divided by 100, which is really just the number 3. Now the tangent inverse button is located above your regular tangent button, and usually you have to hit the second button in order to get that one to appear on your screen. So I'm just going to type in tangent -1 of 300 divided by 100, and you end up with 71.6. So approximately 71.6, or we could even round to the nearest degree and say 72-degree angle is what I'm looking up at for the Statue of Liberty. So this idea of using these inverse trig functions is going to come up quite a bit when we're trying to solve for an angle. Let's look at one more, just generic one, where we're trying to find our theta or our angle, and then we'll be done here today. So we're standing at this theta trying to solve for it, and we have the side opposite and we have the hypotenuse. Opposite and hypotenuse are both in the ratio for sine. So I would set up sine of theta equals opposite over hypotenuse. And then I would say, how can I isolate the theta? How can I get the theta alone? Well, I do the sine inverse of both sides. So I'd have theta equals, and then I'd ask my calculator. Now remember, sine inverse is located above the sine button. Sine inverse 12 divided by 17, and I just type that all in, and I get 44.9, so approximately 45 degrees. So solving for theta still means we have to set up our sine, cosine, and tangent. We just might have to use that inverse piece if that theta right there that we're finding is that angle like we're talking about, okay? So I want to thank you today for taking good notes. We'll be looking at applications as well as using the inverse sometimes to solve for the x if the x is an angle, okay? Thank you again. I'll see you later.